Well, when it comes to chords on our circle, they actually do have a relationship. When two chords are intersecting in our circle, and we see the segments that they have been broken up into, notice those segments they've been broken up into. Well, notice AE times EB, the two pieces of one segment multiplied is going to equal the product of the pieces of the other chord multiplied. The segments of one chord, the product of the segments of one chord equal the product of the segments of the other chord when they are intersecting in our circle. So let's see this in action. Yeah, here it says, in the circle chords PQ and RS intersect at T. We can see that. We want to determine ST. I'm going to label ST as X. We like to see a good X in our problem. Well, I know that X times 9, 9X would equal 6 times 6. That is, the product of the segments of one chord intersecting another equal the product of its segments. So we know 9X equals 36, so X must equal 4. That must have a length of 4. Yeah. Here it says, in this circle, use the expressions for the segment lengths to write and solve an equation for X. We want to find X. Well, I know that 5 times 5 minus X must equal 2 times 2 plus X. Finding the products of those segments. And so this would have to be 25 minus 5x equals 4 plus 2x. We can get all the numbers to one side, and this gives us 21 equals 7x when we add the 5x over, and so x comes out to equal 3. All right, not too crazy, very helpful. Last example, that's right, we're already at last example here. A super heavy passenger jet has an upper passenger deck that is located 3/4 of the way up the cylindrical fuselage. So drew the circle here, we're looking at, it's like you would cut that airplane in half and you see the fuselage, the area where all the people sit, you've got, cargo underneath, or it's very cylindrical. So it's a circle when we cut it. Well, the passenger jet has an upper passenger deck that is 3/4. So here is our height of our fuselage, 3/4 of the height up. We have the passenger deck. So 3/4 the way up means we have 1/4 of the height above that. And because this is the height that's going through the center of our circle, it is intersecting at a right angle the passenger deck. So obviously, you're going to have the passenger deck slanted. It's going to be perpendicular to the height. So that means it's half and half. Half the width of our passenger deck over here, half the width of our passenger deck over here. It says what percentage of the height of the fuselage is the width of the upper deck. We want to know some percentage of the height that gives us the width of the upper deck. So we need to try to find how can we represent the width. Well, I know that because I have these chords intersecting in my circle, I know that half W times half W must equal 1/4 my height times 3/4 my height. Right? That's what we just learned today, and we should probably try to use that here. That's 1/4 W squared equals 3/16 H squared. Well, I want to know about the width. It says, is the width. What percentage of the height of the fuselage is the width? I want W equals. That's my goal. I want to know W equals what? So that's what I'm going to do here. I'm going to multiply both sides by 4, trying to get W by itself as much as possible. That gives me at least W squared equals 3/4 H squared. To get the width completely by itself, I do need to take the square root of both sides. The square root of 3/4 is about 0.87. The square root of H squared is H. Well, we've really already found our answer. What percentage of the height is the width? Well, 0.87 times the height means 87% of the height is the width.